Well, this is different. We're here during the day, and we're actually going to talk about intelligent things at this hour. So, welcome everybody to Non Sequitur. I'm Kyle Curtis. Steve McCrae is over to my left today. Dave is producing, and actually, I'm gonna throw it right over to Steve to introduce our guests, and then when he's finished doing that, we'll go through what we've got coming up for the next couple days, and then get into it. Steve.
Well, awesome. Well, today we're going to be talking about finding meaning in mathematics with Dr. Rachel Traylor and Landon Curt Noll. Most of you guys know Landon Curt Noll. He is a astronomer and American computer scientist, co-discoverer of the 25th Mersenne prime and discoverer of the 26th one when he discovered in high school, and holds 8 mathematical world records and was vice mayor of Sunnyvale, California. Hi, Landon. Good to see you again. And he's also the Jeopardy champion. He's the reigning Jeopardy champion so far, just FYI. Not the real Jeopardy, but the one we play. And
that is his greatest accomplishment, right?
It is his greatest. Yes, he was proud of it. He beat a flat earther, so yes, he was proud of it.
I beat a flat earther on flat earth.
Well, no, actually, I think you tied. Okay. But anyways, Dr. Rachel Traylor is a chief scientist and co-founder of the Math Citadel, a private mathematics research firm. She has previously worked as a research scientist for Dell EMC, as a quality control analyst for Lockheed Martin Aeronautics, and a university lecturer at various universities. She has a PhD in mathematics from the University of Texas, Arlington, specializing in stochastic analysis and probability theory, a master's in statistics, and a BS in applied mathematics, both from Georgia Tech. Her interests primarily are in probability theory, but she'll wander anywhere in mathematics except for category theory. I don't blame her for that. Nobody wants to get into category theory. But anyways, welcome, Dr. Traylor. How are you?
I'm doing all right. Actually, all of my Twitter followers are actually category theorists, so that was me kind of throwing a little joke
shade
at them.
Yeah, a little shade toward the category theorist. Yeah.
Yes.
Do they really exist?
Yeah, they do.
Pardon?
And I find for myself that the areas of mathematics I think I can ignore come back around to bite me and require me to pay attention to them. So.
Oh, that actually was why I threw that, because I used to hate algebra, right? Modern algebra and a lot of the discrete math. Boy, did that come to bite me in my research the last couple of years, where I turn and how did I end up here? Right, I'm supposed to be working with continuous things. Why am I here?
We've all asked ourselves that.
We ask ourselves that all the time.
Every day.
In mathematics, for example, I was very much into the integers, elementary number theory, and this thing like real analysis and all that sort of stuff was like, yeah. And it turned out a lot of the work I had to do with primes and primality testing involved really understanding things like Fourier transforms and error terms and stuff that I thought I could ignore coming around and biting me. And then, of course, there's also a thing of a problem with there was a gentleman in Eredish that gave me a problem that turned out requiring me to understand algebraic topology. And topology was something weird that I said, I can ignore that, and turned around that I actually have to.
And it bit you in the butt, didn't it?
It did. Well, we've had a weird run-in with topology with our work too, although my co-founder is more the topology expert thing than me. So he can do that. I just make it work. So.
Well, I'll tell you what, before we actually jump into the topipic, one second, Landon, before we jump into the topic, how about we have Kyle kind of read some of the upcoming events that we have coming up, because you have cool stuff planned in the next couple of days. So you want to go ahead and
Sure.
get that out of the way? Okay.
Yep. Let's Dave, let's pull up actually tonight. We will be speaking with. There we go. We'll be speaking with Blaine Prince, who is a former IBM employee. He worked for years on the Watson, the famous supercomputer that appeared on Jeopardy, as well as IBM's New Summit supercomputer as part of their quantum computing team to help push the capabilities of artificial intelligence and prediction models. He also worked on IBM's SETI project using artificial intelligent algorithms to analyze satellite and sound data and highlight correlations and help push for the search of life on other planets. So that's tonight at 8 p.m. Tomorrow we have friended forever and godless engineer in a debate on, is it reasonable to take a position that you consider yourself an anti-theist? That is tomorrow at 8. And all these times are in Eastern, by the way. And then on Thursday, I have not heard anything yet from Rick Delano. We do not know if he's still in the hospital or not, or if he'll feel up to the participating in that debate with King Crockett-Duck. I'm in talks now with George Lujack to take Delano's place. We'll have something hopefully confirmed by the time we get back tonight. But again, we wish Rick Delano the very best and hope that he has a speedy recovery either way. And that's all that we've got coming up for this week that we'll go through. And now let's get back into mathematics. And I have my EpiPen. I told Dr. Traylor before the show started that I am allergic to math, so I have my EpiPen by my side. So if you see me break out in rashes or hives, you know what's happening. I'll try to keep up though, I promise.
In other words, be gentle in the math area. Yeah.
Could I suggest that a lot of people are allergic to the way mathematics is taught? And they probably don't understand what mathematics is or what a mathematician does.
I will second
That's fair.
that with
Maybe Dr. Traylor, you can kind of touch on that exactly. What do you do, and what kind of preempted this, or not preempted? What kind of led into this whole discussion? The fact that I was talking about how, well, you were talking to me actually of how people can use mathematical terms incorrectly, or just vagueness in certain mathematical terms can lead to weird results. Correct? Something along those lines.
Yeah. I guess so. Since I've probably been searching for a while in my admittedly not quite as long an illustrious career as Landon's, but how do you actually sum up succinctly what a mathematician does for a living? Most of the stereotypes that come up, oh, your board is covered with things and you write papers and, you know, your desk is a giant mess. Like, well, yeah, that's actually all true. It's very true. But what I do for a living is ultimately what I see myself as is someone who fills in gaps, right? My analogy is taking it like engineers I typically are ones, I work with engineers, even though I'm a theoretical mathematician, what they're doing is finding out, hey, we do something like say flight, but we were able to plane that flew long before we understood fluid dynamics fully. You know, even then, it's arguable we don't fully understand it yet. So who comes in those gaps of understanding that takes you from, you know, the Wright brothers biplane all the way to C-130? Mathematicians. And that's what I do. I'm essentially your plumber. I come and fill in the gaps and make sure that the foundations you're building your house on are going to last. That's my like non-mathematical summary of what I see myself as doing for.
Excellent.
I think we can keep up with that so far.
Yeah, and I think, you know, there's a lot of people that think that mathematics is arithmetic, right? That they think we go and, you know, add numbers and multiply numbers all the time. And the quote introduction they have to mathematics is years and years of memorizing the addition table and how to do long division and other painful operations. But if I can use an analogy, arithmetic is to a mathematician like penmanship and printing is to an author, right? Somebody who writes a novel probably has to know some basics of how to write letters down, but that's not what they do all day. They compose complex thoughts in hopefully a coherent fashion. And that's what mathematicians do. We write, when you're doing real mathematics, you're writing novels. You're not wasting time printing letters and spelling things.
No, I agree with
Excellent.
that. You know, yes, I do some of the tedious arithmetic. So, you know, kids that are watching that high school algebra matters. You know, expressions they make you reduce. You would be amazed how much of the algebra tricks you hope you can forget about that I still use on a day-to-day basis. It's annoying.
Yes.
Still there. It never. It's almost like mathematics can touches so many things so many places that it becomes almost difficult to see the value in it because it's so far underneath everything. You don't really appreciate the underground river before you drill the well, but it's still there and you still need it really bad.
Very, very good. And when you talk about STEM, there's a reason why there's an M in STEM. Mathematics occupies a very unique relationship with technology, sciences, engineering, and those sort of things. It's one of the real important foundations. And I wish we would be able to change our educational approach. Even when I talk to people about how mathematics is taught outside the United States, I think we lose a lot of potentially great mathematicians by boring them with memorizing the times table.
There's a place for that, and to be able to recognize patterns and convenient mathematical simplifications and whatnot. Simply, sometimes you just have to do drills. But when it comes to, it's either drills or this weird mishmash of what I don't comment too much on general math education, but because I've only done it at the university level, so I guess I've only seen the results, if you can get. But what I get when I've taught mathematics is people who are really good at memorizing things, and I switch the variable name in, say, I don't teach like upper division calculus, Calc 4. We're talking multivariate calculus. If I switch the name from X to theta, what happened? I'm
if I can interject real quick, you're breaking up just a little bit, and I think Kyle has a suggestion for you, Dr. Traylor, to kind of fix. You're breaking up a little bit, not much, but a little bit.
It's clipping a little bit because I use an iPad sometimes too, and what it is because you're using the microphone on it, the iPhone has, or the iPad has a like a noise gate on it that you can go into your settings under, and it says reduce background noise. If you turn that setting off, it'll fix it where it doesn't clip, because what it's doing is it's trying to cancel out any background noise. So it's making you clip a little bit.
So while she's doing that,
let me fix that.
One of the things we do here at workplaces, we have a board over there where we put sort of math problems for people to explore on. And I find that one of the clever ways I can do to keep people from sort of quote Googling the solution is just changing the variables around and changing the form. And those that know how to reform the question don't need to go Google the answer. There's another thing also I really like about mathematics. You do not find at a mathematics conference someone standing up and saying, in my opinion, 2 + 2 = 4.
Right? Opinions don't mean much in math, does it, right?
I'm going to interrupt briefly.
Go ahead, Dr. Traylor.
Again.
One second, Landon. Go ahead, Dr. Traylor.
I'm going to one more time just to ask where in the settings that is, just as a repeat for me.
Okay, if you go into settings, and then do you have a button that says sounds and haptics?
Ooh, would that be under general?
I tell you what, let me find it.
I'm so sorry.
No, you're fine. If you go to where it says call, there should be a thing that says either call, phone, or FaceTime. Do you have a button that says phone?
In the settings? No, this is a Wi-Fi only iPad, so I don't have that. I have a FaceTime.
Okay.
I have a FaceTime one. No, it's cool.
So in settings, in the fourth section where it begins with general, there is 4 down something called sounds.
Okay, so that one.
Okay, now where is it you're talking about?
Well, it would have been under like if she just has a Wi-Fi only iPad, then it's something else, because if you have an iPad that's you're able to get cellular data from, it does have that setting that allows you to have that noise cancellation. But if it's a Wi-Fi only, you can't make those calls out on it, so it wouldn't be on there. So it's probably going to be a different.
phone.
A suggestion from wait, one sec. A suggestion from Jamie was to pull down the search bar, which appears in settings, and type in reduce.
Okay.
Yeah, it's like because in mine phone noise cancellation comes under general / accessibility.
I have reduce white point or reduce motion.
Okay.
When I
if you go up to the search bar and type in noise, you will get,
Okay.
How about the search bar in the general?
Phone noise cancellation. All right.
There you go.
So
Click on that.
There you go. Try that.
I clicked that, and now it's taking me to accessibility, phone noise cancellation. I'm so sorry to be derailing this.
Oh no, you
that's
sound
fine.
good. It's not
No, that's
clipping
okay.
now. Now it sounds great. I don't know. Weird.
Yeah.
I didn't know that you had that without the cellular one. So we learned something out of this.
I'm not gonna lie, I searched it, and it's still not showing up in the actual menu. So
I'm looking.
Well, you're
I'm
not
looking
clipping
for
now,
it.
so.
I'm looking for it as well to see where it is on because it is under accessibility. But the question is, where is it now? I don't see it on mine because I have both Wi-Fi and not.
Okay, good. I'm glad I'm not.
It's not.
This is why I have Windows and Linux.
All right.
Linux.
It's
Every
under
mathematician should have Linux, people.
It's under accessibilities and then down under hearing.
Oh, hearing.
Yeah.
Okay, so I see under hearing devices and then auto
mono audio. Is that what I'm looking for?
It's right under mono audio.
Oh, there's an L and an R, basically a slider.
Yeah, I'm seeing the same thing she is, and I'm not seeing the phone noise cancellation there.
That means it's they don't have that option on the Wi-Fi enabled one. So it's a different issue.
Well, I have a Wi-Fi enabled one, and it's not on mine. So anyway,
what I would recommend is what I would recommend is just don't change your distance from the mic too much. Kind of keep it, and that way it's not going to go up and down. It won't have that noise gate as much.
All right.
Okay.
So sorry to bother people about.
Sorry,
They're
guys.
used to it. They're used to it.
And real quick,
right,
guys, before we get back into it, when you come back to Safari, you might have to drop out and come back in order for it to pick up your camera. Because right now it's just a black screen, and if you try to come back, it's just going to pick up your voice. For some reason, Safari makes it where you have to drop out and come back in to pick your camera back up.
So
there you go. You're back.
There you go. Now you're back.
So sorry, everybody. I'll keep my distance pretty constant from the microphone.
So did you want to go into what you were talking about earlier, how certain mathematical terms kind of differ when you talk to engineers and how the rigor kind of changes how things are understood by engineers and other people and non-mathematicians?
So I have I would say an intimate experience with this because everybody's hyped up, especially in the Valley, on things like data science, AI, machine learning, all this other junk. And I do have a statistics background and probability. And so certain words have, I would say they've been stolen by marketing and kind of ruined. So for instance, the notion of bias, that has a colloquial meaning, but it also has a mathematical meaning. And so if you're going to use that colloquial meaning when talking about things that ultimately have mathematics underneath it, it's important to actually define what it is that you mean. We have the notion of bias, in your, I don't know, your political leanings or the way you write articles or whatever, but that's not the same as mathematical bias, which is simply it's just the difference between, so if I'm going to use data to try to estimate some kind of parameter, say the average height, right? That's your classic example. Well, I don't know the true average height because I'd have to take the heights of everybody in the entire world and then average them, and that's not going to happen. So we grab a sample and I'll average, I don't know, 1,000 people. That's a really crappy sample. Don't do that, guys. That's a horribly small sample, but whatever. Let's just say we do that. And you use the sample mean. Everyone's familiar with add up the numbers, divide by the number of things you have. So that is an estimator of what you're hoping is the true parameter. And that estimator itself is random because every time I take a new sample, something like the heights are going to change. So that thing itself as an object is a random variable because every time I put new data in, it's going to change. But it itself has its own probability distribution. And the expected value, basically the mean of the probability distribution of that estimator, we want to know how close that is to the actual parameter. And this, like I said, forget the data, this is all theoretical. And the bias is the difference between the mean of your estimator and the actual parameter. That is a strict, rigorous, definition. So, when you say something like the word bias and then you start talking about neural nets, we kind of need to be a little more careful about what do you mean when you say that? Because if you say that your results are biased, but you're talking about the results of a statistical analysis, that actually has a very specific meaning here, which I don't think is what most people mean when they use that word. So if we can't agree on a definition, how are we supposed to have any kind of conversation that isn't just like semantics that devolve into, pardon my language, a shit show? And that's one thing that, frankly, if I were going to advocate more in mathematics education, forget the equations, forget all the terminology, the notion of being rigorous and well-defined, which, by the way, also has a meaning in mathematics. Yes. Everything we do, we cannot move further in anything we do, even if I'm creating something that's never been created before, until I have defined it and defined it rigorously and well. We cannot move any further than that. So, other things like you'll probably find the notion of convergence, especially in tech. I don't know what hyperconverged is, but I heard it and I was like, why are you taking my word and abusing it? Other ones, for instance, the word integral, right? That has a colloquial meaning. Something is integral to your, I don't know, having trouble coming up with a colloquial example. It has a colloquial meaning.
Integral to your way of life. Yeah.
Yeah.
Sure.
Like the internet is integral to my way of life. I can't live without the internet, obviously.
Right. But in mathematics, obviously an integral is that pretty little s that is a continuous sum of things. But it also can refer to integers, right? I'm working on an integral valued function. In other words, I'm only working, on functions that are defined on the integers. But we have a definition, and they tend to sometimes depart quite strongly from the colloquial use. And so it's important to be clear about that when we talk about it. Other ones would be things like that seem vague, but are actually not. For instance, I'm an analyst, which is a specific branch of mathematics. I might talk about something almost everywhere. That sounds super vague, right? Actually, that has a meaning. A very specific meaning, almost everywhere except a set of measures here. I promised I wasn't going to make anyone break out EpiPens, so don't worry about that. But the point is, even vague sounding terms in mathematics, we define very rigorously. So when I say I converge almost surely is another kind of twist on that. That's not me going like, yeah, I'm like pretty sure I'm getting there. No. And where I see this kind of breaking down is when, especially tech seems to be this weird gray area between the colloquial and marketing, but it's built ultimately on mathematical principles. And so when the colloquial breaks down and takes words from essentially the mathematicians or the engineers that have built something, and they start breaking that down, we end up in a whole bunch of trouble where now you can't even tell me what hyperconverged infrastructure is, because what does that even mean?
Yes.
Right? Everybody's claiming it. And, how can we have a conversation? How can you decide what product to buy if you have no concept of a definition? That's one thing.
Sure. Go ahead.
Yeah, it's something that I find lacking to the point where people almost don't appreciate it. It's not fun, right? To sit there and argue about what exactly do we mean before we have a debate on whatever it happens to be. But how can you move forward with anything unless we're starting from the same point? And that goes beyond mathematics.
Yeah. And I think mathematicians run into this problem where you're in a room with smart people, engineers, other scientists, and people begin to express things that are quasi-mathematical. And then that's where the mathematician objects and saying, well, wait a minute, convergence means something. Are you using it in the mathematical sense? Are you doing vagary? I mean, a good example is Steve and I had some wonderful discussions around logic. And there's a very fundamental difference between philosophers that talk about logic and a mathematician, right? And by the way, the difference is fun, right? We end up with various dumpster fires as a result of
frequently.
But you know, it's and I'm not saying that what they're doing is wrong. I'm saying what they're doing is different. The problem comes is that when in a technical discussion, expressing things in a sort of mathematical form, that's when you run into problems.
Well, maybe we can kind of break it down a little bit. I don't want to go too far over everybody's head, but like you use the term like hyperconvergence. You said it's being stolen from the mathematicians. People that may not know, convergence is something like if a series converges to a number or a sequence converges to a number. But in hyperconvergence, that's more along the lines of what you do, which is like IT domains and stuff like that, right? That you're training these engineers because you work in cloud computing. So they're using this term hyperconvergence in a way that's different from what a mathematician would use convergence, right? Is that the premise here?
To be honest, I have never gotten anyone in the tech sector to define that for me that isn't like changing with the person I ask. So I have no idea what they mean by that.
I think our producer's a tech guy. Has he heard the term? Dave, have you heard the term hyperconvergence? Because it's a term used in IT, but and I'm not that familiar with it. I've seen it around, but I don't know what the actual
Why would they do that,
definition
though?
is. I'm not going to look it up.
Because it
why are
sounds
they
fancy and it
doing
sells otherwise.
Yes, yeah,
boring
fancy.
stuff.
Okay.
Yeah, hyperconvergence, man. Isn't that better than regular convergence?
So
Yeah.
marketing is the
Marketing
reason behind it.
Yeah, they do use it in marketing quite a bit.
What does it mean,
Yeah.
Dave?
So one of the things that you find is actually hyperconvergence is used. I actually the top like for example, maybe hyperconverged infrastructure, right? And this has to do with a lot of, let's say, storage systems being defined by hardware. And so hyperconvergence is the marketing act of using so-called hyperconverged facilities like an infrastructure. Now, why was it done? Because marketing looked for a term and pundits looked for a unique term that they could blog about to become known as the person who, quote, invented hyperconvergence. What they did is they stole a term, bastardized it, made it sound technical, but in the end made something very imprecise.
Yeah, maybe I'm weird, but when I hear hyperconvergence, and maybe people might get this, I think of convergence rate. I think of how fast something converges. Would that make sense to a mathematician? Whether you have a slow convergence or a fast convergence? Because I hear hyper, I think of a very fast convergence rather than like a slow convergence series.
Yeah, even I as a mathematician, like I try to avoid I don't know what sound like we try to avoid sensationalizing things. So the word hyper is just like, whoa, and even that is vague, right?
I mean, it's like, is it like multi-dimensional, multivariant convergence? I don't know.
So with the exception of say, like algebraists, I'll pick on you, Landon. We like our terms to be very obvious. So if I say something like correlated, well, let's not go to that one yet. If I say something like, a continuous something or other, we try to name things in a way that's descriptive. I'm going to pick on algebraists with all of your morphisms. Oh my God, why do we need 5 different names whenever we change something? I need a dictionary every time I have to deal with this in this space. But, we name things. One other peeve of mine, and actually it's not, it shows up in mathematics. Definitions cannot be relative, right? You cannot define something relative to something else. And here's where my peeves come in, because in particular, because statistics is such a relatively young field, we haven't kind of filled those gaps yet. The notion of statistical independence, right? That the information contained in one variable has no bearing on the probability of the other one. It is a quick summary. So we actually can say in a mathematical sense what it means for two variables to be independent. Next, what does it mean for them to be dependent then? The only thing that we have is not independent. It literally is the negation of independence. Small plug, I actually am working in this space to define what that actually means and build that out. But like I said, I promise no EpiPens, so that I publish all my papers on my site. Go check it out if you're really brave, or whatever.
I tried reading one of her papers. I didn't get very far, just FYI.
Yeah. But the thing, at least I say in
blog actually
mathematics,
was,
the terms are supposed to be well defined. And
Yes.
and when you're presenting a mathematical paper, you need to state what is your axiomatic system that you're building upon.
Yes.
And then take it from there to try to show something or to state something. And again, you're not stating an opinion. You're bringing forward facts, right?
So
you
when
don't
we
have a flat Earth mathematician, right? There's no mathematics
Are you
is
sure?
or it isn't. Right?
That's
Are you sure?
They
that's
say there's
probably
one. We have been told there's one PhD in mathematics that they think the Earth is flat. I don't know who it is.
No.
Maybe
I'm being very precise. You don't have this notion of well, in my opinion, this is what mathematics does, right? Your opinion doesn't count in mathematics. That's what I mean by. I don't mean that there aren't mathematicians that are flat earthers. I'm saying there's no sort of flat Earth equivalent in mathematics.
Right.
Sure.
I got
I
you.
guess one other thing that this is where the colloquial use gets me is actually in the word proof. I proved X, Y, or Z. Okay, look, as a mathematician, stop abusing that word, please. Please stop abusing that word.
Scientists use that word too. I mean, in science, you don't ever prove anything. You can't say I prove that such and such exists. You don't ever do that in science. Science is alternative.
I may piss off some scientists by saying that, but when they create they do an experiment, great, even a highly reproduced experiment, fantastic, and say, well, this proves X, Y, or Z. Wrong. The only thing you can prove is by using axioms from mathematics. What you can do is suggest very, very strong evidence in favor of something. But me simply just, they're essentially trying to take what we would call an exhaustive proof. So if I had said, well, every time I add 1 to a number, I get the next natural number, right? If you decided to prove that by if I add 1 to 1, I get 2, and that's the next one. Okay, well then, now if I add 1 to 2, I get 3. You're never done, right? That's an exhaustive proof. You cannot ever be done, which means you never finish. You've never finished proving it. That's science. Experimental science is never done. Proofs belong to mathematics. Results and evidence belong to science. And like I said, I'll probably piss off some scientists for that one, particularly physicists, but sorry.
But it's also interesting.
I agree with you. I mean, I know a little physics, and I think you're spot on that one.
Yeah, but it's also interesting that mathematics also has proven that the proof process is, if you will, limited. I'm trying to avoid talking about incompleteness theorems and so forth. But the notion that mathematicians at one time, many mathematicians, let's say in about 2 centuries ago, thought that you could build a machine where you pour in axiomatic truth and out would come more and more proof. So you could just sort of generate by machine mathematical statements. And we found, to our surprise, that process is limited, and that the notion of formal proofs is not able to derive everything.
One misconception I find when I've talked to people about mathematics is there is a lateral creativity that involves that is part of being a mathematician that I think people don't understand. I'm not an automaton. the last paper I wrote was on probability theory, and I ended up in graph theory to finish the proof because, like, why? You know, that lateral reach over there, that's not an audit. There's a creativity there that is something that's underappreciated, and I don't know, maybe we as mathematicians are really bad at, you know, artists, maybe because we, like, people think we don't feel, right? That artists feel, artists create things. Mathematics creates too. There's a lot of creativity that's involved in that. Just because the creativity follows a rigorous set of axioms does not mean we're constrained, or computers. And that's a misconception I don't know how to clear up.
It's because when you're trying to solve a problem, particular problem where the odd numbered answer is not in the back of the textbook,
Right.
sometimes you don't know whether or not you're able to solve the problem, or you need to build new structures to approach it, or come with a completely different approach. I mean, remember, you know, Dr. Lamer, sometimes we were discussing things and trying to work on a problem. He would sometimes say, hey, let's go get in the elevator. Well, why you go get in the elevator? Well, you go in the elevator and basically the idea is you begin to go home, right? And oftentimes he would, as we're going down the elevator, he'd press the stop button down on the floor, go in there and say, I just got an idea. Let's go back up there and try it again. It's that act of leaving, clearing out your mind. But sometimes we go down the elevator, we get to the bottom and we say, okay, we're done for today, and would leave.
I think it might actually help for people if you do kind of explain incompleteness theorems, because you actually described them, but you got, you know, but you kind of left it hanging. And I think the people in the audience kind of would like you maybe to kind of explain what the incompleteness theorems are, at least one of them, the first one.
Oh, go for it, Landon.
Okay, let me again, and then use
in a
things in a
layperson's
math
way.
In a layperson term, you start with a set of rules, right, that are as capable of describing what numbers do, right? Describing the number line, describe how we add and multiply and other properties of the number line. So it's rich enough you can describe number theory, right? Let's say you have that set of rules is either going to be unable to prove certain things that have a truth value, or it will contradict itself, that you end up with logical contradictions showing you that you've got some issues with your fundamental rules, or it's going to be a system which is trivial. I mean, a trivial system is, I have an axiomatic system where a thing is itself, and that's all I have.
Also has
You
a
say that,
mathematical
okay.
definition. Trivial has a meaning.
Yeah. Yes. So
Is it true though? Any proof that's actually proved automatically kind of becomes trivial? Is that the case? If something actually is proven?
No, I don't. I wouldn't call proofs trivial. Some proofs are not trivial, but the point is that you cannot take rules of mathematics and derive everything. There are mathematical statements which cannot be formally proven given any axiomatic system, any set of rules, right? You're not going to start with a set of rules and derive everything, right? You're not going to be able to derive all truth. And
There's
furthermore,
no one system that can prove everything.
That's correct. It's impossible to basically have a fully self-contained system.
That's fun because when you're working on a problem, there's a wonder, is this one of the problems that is outside of I'm unable to prove or not? And that's and the joy of actually discovering a proof is like, oh yes, it is within the system and it solves it. So the notion that all truth can be determined and known, mathematics says no. You're either going to your system of rules is either going to miss things, or there's going to be inconsistencies, that it'll contradict itself, or it'll be a trivial thing on the side that people will say, who cares?
What I generally don't like when this comes up, though, for non-mathematicians, is that I don't want it to be used to destroy the notion of mathematical logic, because that's what I've kind of seen before, is like, well, if it's not perfect, then it must mean that, mathematics and logic is basically useless, and therefore we can just dismiss it. No, it just means that there are axiomatic limitations. You know, I can't create a perfect system. That's all that means. I can't create one perfect system that explains the whole world. We have to create multiple ones.
You
And
cannot
can you
take a
tell-
computer. You cannot take a computer and say to the computer, prove anything I give it to you and have that computer succeed.
Can you kind of explain to people what you mean by an axiomatic system, what an axiom actually is as far as mathematics?
I have to be really careful here. Because then you'd start diving into, I'm going to explain it more in the sense as an irreducibly self-evident statement. And I'm going to try to be really careful. So if there's a hole in that statement, Landon, feel free to correct.
No.
Self-evident is where I'm trying to avoid that word, but I'm trying to figure out how to get around using that word, because it basically can speak to, oh, well, mathematics isn't that different than a religion. You just choose to accept things that don't need proof at all and then prove things based on them. That's a difficult topic for me to feel like I explain well.
Yeah, but
Why
mathematics
is that? Because of the
these-
arbitrariness of them? Is that why?
Yeah, it's not arbitrary.
No.
I mean, these
Right.
fundamentals
Well, it's not. They're not
just-
arbitrary, but I mean,
They're
but
not
there
your
are certain
opinions.
axioms you can take, right? But there's certain axioms that you can take and certain axioms that you can't, right? But I mean, they are kind of the building blocks of any mathematical framework.
Right.
in a
And how do you
nutshell.
decide that that's the smallest, right? It's an irreducible building
Yeah.
block. That gets into more the mathematical philosophy, and there are mathematicians who work in that space. I might recuse myself from this one because I don't really work in that space. So I try not to make comments on things that I'm not an expert
Sure.
in.
Yeah. There's a thing
Wow, that's
called
rare.
logicians. There are logicians
very rare.
that are people who work in this proof space. They're very frustrating people to talk to, because
But
whatever you say, they will end up asking you questions that don't seem obvious to you, but to them, that's the space they're working in, right?
I want to make a huge point here, because this is something that needs to be noted. Dr. Traylor, you're not the first PhD we've had on here that says, you know what, that's not my area of expertise, and I'm going to kind of recuse myself from that. And that's the difference between somebody who actually knows their shit and somebody who doesn't. Because when you get a flat earther in here, they're fucking experts in everything.
Not just flat
Everything they're
earthers, though.
expert in.
Not just
Well,
flat
not just
earthers.
flat earthers, but some people, you name, they know physics, they know math, they know biology. I mean, just literally, they think they have PhDs and everything. So I think that's a wonderful thing when somebody says, you know what, that's not my area. Even though that you probably know more about than anybody, obviously, who's watching this. I mean, we have some pretty smart math people in the audience actually right now, but still, you're still
rare.
epically above them. But even you will say, you know what, I don't deal with that kind of stuff. So let me kind of stick in my lane there of my expertise. And I think that is just amazing. I think that's what an expert does. That's the difference.
And you're never too old or too young to learn. But one of the things you need to be able to do is to say, I don't know, right? And because I don't know is the beginning of, well, I can find out or talk to someone who might know the subject better and convey some knowledge.
It's my middle name.
Well, we have smart people. I mean, they're ask you guys about axiom of choice. I'm like, we're not going to go down that route. No.
I don't touch that.
Yeah.
As I say, now,
ZFC, no.
Now, if you think of look at the background of this show, we have a chalkboard that's self-written. I recognize Feynman's writing there. I believe that looks like Feynman's writing, and looks like some of the stuff he works on. So I had the joy as a young kid to have a conversation with Feynman, and we talked about proofs. Right, I had just used a couple of Seymour Cray's machines to prove primality of certain numbers and prove a property called perfect numbers of certain properties. And the question our discussion is, well, what does it mean to prove, right? In one sense, I did not prove the primality of a number. What I did was I showed a number had a property. But how did I do that? Well, I had a computer perform calculations. And the assumption is the calculations were performed correctly. Now, one of the ways that you try to convince other mathematicians is you produce, a paper and get other mathematicians to try to verify your work. And so I had two very wonderful mathematicians, a lady named Emma Lamer and a guy named Dietrich Lamer, that independently perform the same operations, the same work that I had performed, came to the same result using independent methods. And they both came back and said, yes, we did the same thing as Landon, and we concur. All right. They didn't say he's right. They say we are in agreement, right? Which is a very mathematical.
There's a distinction. There's a distinction and it can be, oh, well, as long as other mathematicians accept your work. No. It's either true or false. There's no in between. There's no majority vote. Even poor Cantor, if it were a majority vote, that poor guy, he had it rough, man. That mathematician had it rough. But he was right, and provably so. The proof doesn't care how many people agree or disagree with you. It just is.
It's not an opinion. So can a computer perform mathematics? Well, in some sense, no. Can a mathematician use a computer in the pursuit of mathematics? That answer is yes, right? We call that, to use a dangerous term, experimental mathematics.
Would that be similar to like constructivism, like a constructivist math? Would that be something similar?
I don't know. I'm not sure what that would. But I mean, Rachel, I was asking you, a question. Has anyone proved the primality of some of these large Mersennes? Is that I've published a paper that's been peer reviewed, and my results have been checked independently, but has like the four-color theorem been proven?
Yeah.
Right. What do you think?
I guess I was going to actually address the constructivist point.
Okay, please.
My understanding of that is, so this comes up in analysis in my branch of mathematics. So there's the notion of, if I can prove the existence of something. I actually had to do this in my dissertation. I wanted to prove the existence of a bound for something. Like I said, no EpiPens here. A constructivist would say
Kyle's
that
not shaking yet. You're doing fine.
A constructivist would say that this is kind of probably a difference of opinion in mathematics. A constructivist mathematician would say that my proof would not be complete unless I told you what it was. In other words, it doesn't exist until I have found it, not just I have proven that it exists, but I don't know what it looks like yet, but I can show you that it exists. There are mathematicians that do not accept it exists, but I don't know what it looks like. In other words, you're not done until you can tell me what exactly it is. I'm not a constructivist otherwise I wouldn't have got my dissertation done. I do believe you can prove existence and not know what it looks like yet. But there are mathematicians who do not accept that, just as there are some who do not accept the axiom of choice.
Yeah.
But yeah, that's my understanding of it.
But can you accept a proof that includes a computer performing some computations?
Ooh. See,
You mean a
And this is
computer generated proof?
this is what Feynman and I had a discussion with.
Are you asking
Feynman
if it's
took out-
actually a proof come out from a computer? Is it acceptable? A computer generated that. You're not asking it to validate a proof. You're asking it to come up with a proof. Is it valid? Is it a valid proof?
No, if we're going back to the primality
asking?
thing, verification of primality using basically, success or using computation, is that a proof? I think that's the question we're
Yes.
kind of addressing.
Okay.
I would actually say no. But it's a weird line for me because, if you ask me like, well, why not? I don't have as clear an answer for it as I think I should to have as strong an opinion as kind of internally I feel like I do. Which is generally why, like, I would say internally I have a strong feeling towards the answer of no, but since I can't give a good description as to why exactly where is the problem with calling it a proof, I would say that externally I'm still open to consideration for arguments, and I think that's still a kind of an open debate among mathematicians as it is.
Yeah, and that's the thing that Feynman's discussion was, he said in physics, they have results that they are extremely confident in. And sometimes physicists will say, this has been proven or this has been shown. And so we were talking about, well, what the computer did. And the answer is, I can tell you how to prove the primality of let's say, a given Mersenne prime. And you can perform the calculations. But you as a person would not be able to perform the calculations in your lifetime. They're just too enormous. So you need assistance of a device to do the processing. And the worry or the question is, well, is your process of that calculating correct? But I can go and do equations on the board over here, miss flub a minus sign and a plus sign, produce garbage, think I've done something when I haven't, right? So humans can get misled by mistakes. The problem is computers are also fallible. In the modern primality testing and modern computation, we are dealing with calculations that are much longer than the mean time to error of a computer. The computer you're watching this on is a machine that makes mistakes on a regular basis. The equivalent of 2 plus 2 comes out 5 on occasion. In mathematics, when you perform these primality tests, you must be exact. You must be correct. There is no error. The integer calculations must be performed to the last, the last digit correctly. Otherwise, it's garbage. And computers are very imprecise from a mathematical point of view. They make errors. So you have to do a lot of work to show your computer was correct in its calculations. In fact, sometimes you do more work checking your results than the results themselves.
The live chat is going crazy. They want to know your opinion about the proof for the four-color computer-generated four-color theorem proof. Now, for those of the people who don't know, you might want to explain it, what it actually entails as far as the boundary conditions and adjacent colors. And I know very little about it, so if one of you guys want to explain to people, but the audience seems to know a lot about this four-color theorem. I just know what it is, but I have no idea what the computer thing was. So, all yours, Landon or Dr. Traylor.
I'll let Landon do that one. Like I said, he's more the discrete mathematician.
So let me, again, with so you don't need to do your EpiPen. Let's say you have a map,
I'm getting you ready.
Piece of paper. You have a paper with a bunch of boundaries defined, like states and countries and so forth. And you decide you're going to color each region. And so you take the first region and color it blue. And the adjacent, and you say, I want the adjacent territories to have different colors. So the territory that's next to it, I might color green, but there's another territory that's also next to it, I'll color yellow, and another one red, right? And so the question is, when you have a map, arbitrary map that can be as twisted as possible, but exists on a flat piece of paper, how many colors do I need in order to color each region with a different color such that no two regions next to each other have the same color? How many colors can I get away with? And it turns out the answer is 4. In any plane that's been carved up into pieces, you can take 4 colors, apply them to boundaries such that no two boundaries have the same color next to each other. And in other words, the answer, the statement is 4 colors suffice. And mathematicians had a number of approaches to this problem where they narrowed it down to saying, if you can verify that 4 colors suffice for this large set of combinations of things, it's proven. But they weren't able to do that last step. So a computer was used to exhaustively go through the remaining possibilities and show that it could color each of those patterns with 4 colors correctly. And therefore, the statement was 4 colors suffice. And there's a big debate, has it been proven? Now, mathematicians are looking for a proof. And there's some mathematicians that believe that we can construct a formal proof without resorting to exhaustive search by computers.
Colors have to exist first, though, Landon.
And so colors is merely assigning a property to a region, if you want to be
that's been an ongoing debate for ages now.
Yeah, it's an ongoing debate for us here.
I mean, I'm trying not to become, pedantically precise, but essentially any map you see, you can use 4 colors to color regions such that no 2 regions that are adjacent to each other have the same color.
Landon, hang on. You're on Kyle's side on that one, right? Though you think colors exist, Landon.
I don't understand.
Are you one of those crazy color people that think colors actually exist? Oh, Landon's stunned. He got frozen. Uh-oh.
Landon,
I'm back.
Oh, there you are. Okay, you're back.
There you are. Please, you believe that colors exist, right?
To be fair, I don't understand the question because I believe you're asking a philosophical.
Second.
It is a philosophical question. It's color realism. I hold a color realism. I think most scientists, the cognitive scientists especially, treat colors as a phenomenon in the brain. It doesn't have any.
But here's what
outside of the mind. So
here's what she's talking.
The colors don't exist. They're just a phenomenon rather than a noumenon.
I mean, Steve, this is, for example, what she's talking about. You need to define what exist means. You need to define what color means, and then we can give you a mathematical approach.
Goody.
To exist, to have being ontologically in the universe, and color would be a perception of. What's a good way to define color? Perception of.
But isn't that where you're getting stuck? Right? You're already kind of biasing the results by saying that color is a perception. You're leading the question.
Well, it is a perception. Well, I look at it this way. Do dreams exist? Do you think dreams exist? Do they have any ontological reality outside of the mind?
Okay, so to you, existence means we've stepped, as in, outside of my mind. So what's inside of my mind may or may not, existence must have some kind of property outside of my head.
Correct.
Okay. Do dreams exist? God, I hope not.
I mean, I think part of the problem is in a mathematical sense, I'm trying to think about set theory and say, well, I have a set of things that exist. Is this item well defined and a member of that set of things that exist?
Perfect. I'll explain it. I'll try to relate it. I'll relate it in a mathematical way. Are you Platonist? Are you a mathematical Platonist? Do you think mathematical numbers actually exist in some kind of Platonic realm?
So does the number two exist?
Physically exist somewhere, yeah.
Physically exist. So now you change the.
This is getting weird.
Not really, because if you're a mathematical
Platonist,
it does exist on some form. I mean, obviously, I treat numerals as just symbology to represent an abstract concept. A number to me is an abstract concept. Except if you're a Platonist. If you're a mathematical Platonist, you think they exist. I'm a nominalist.
A number theorist can precisely say there exists a prime that is 0 mod 2. Right. That's perfectly acceptable.
Yeah,
right?
But this is a perfect example, I think, though, of how the word "exist" will be different in philosophy than it would be to a mathematician. Because in a mathematician, when they say something that exists, they don't mean it in concrete. They don't mean it by what's a reification. They mean it as that. If I say like a real number exists on the number line, there's no real number line that physically exists. But in a philosophy, existence is more ontological, is metaphysical, rather than something to be treated as an abstract concept.
What do you think?
So
Everybody's
this is
laughing,
where
going, "You asked for this, people." Well, go ahead.
this is usually
This is the best part of the
where,
show.
when things turn to philosophy, I tend to recuse myself, only in that we have to spend so much effort trying to figure out how to get on the same plane. So I don't feel like whenever I give
Amen.
whenever I give an opinion that would be considered philosophical, I don't like when things aren't like, I can't say that my explanation is perfect. So, you know, for instance.
Oh, you hate philosophy then, yeah.
I mean, I took a number of philosophy courses, but I purposely audited them. I did not want philosophy to be pure as part of my GPA. And it wasn't out of disrespect for philosophy. I just did not want to think like a philosopher.
For me,
Agreed.
where it gets difficult is, I mean, I know that we say I mean, I can create things in mathematics, right? I do. But philosophy for me has this weird, no offense to philosophers, but, and I realize mathematicians have the tendency to do what's called navel gazing, but oh my God, philosophers. You know, where you're getting to the point where you've spun yourself in circles and twisted yourself in knots where you can't even figure out the meaning of is, to borrow like, I'm not that young, okay? I know,
Yes.
I know where that's from. When you've twisted yourself in knots to that point, now, you know, say when you're getting to the implication P implies Q, now you don't even know whether P is true or false. So of course, P implies Q is always true. Like you can make it say whatever you want because you've kind of figured out it. You've almost deconstructed your hypothesis to the point where it becomes meaningless, which is kind of, you know, I don't mean to trivialize it to say that like these are stupid questions or like why are we even talking about this, because that's not fair. But it gets to a point, and I did actually listen to some of your shows. I was curious. So
wait, which
I
ones?
think if I
Which
were-
ones?
Yeah, that's what I want to know now. I'm like, wait a minute. Yeah, because before it was like, who the fuck are you people? Now she's like,
well,
oh, I did watch a few.
I had to do my background.
And do due diligence.
Just all
Gotcha.
sorts of
See,
different.
that's a mathematician. Yeah, that's
Particularly the
mathematician for you.
debates, and I think what I found in the debates was where it seems like when we say it becomes a dumpster fire, we start arguing semantics and get away from the topic at hand. And that's where you start getting into what is the meaning of is, and you know, why are we all of a sudden talking about weird stuff in spectral while we're talking about Big Bang? I mean, I get why you might go that direction, but it's not addressing what's at hand because no one can agree on the definition of what we're talking about to begin with, and no one wants to recognize that that's the fundamental issue, rather than just I'm going to start pulling more facts.
But isn't it critical? Doesn't that make even more sense to talk about about being on the same page for definitions when you're having discussions, when you're having debates?
Yes.
Then
yes.
the semantics. It's people. I think it's weird when people kind of say, you know, it's a semantic argument. I think semantic arguments are what makes an argument great. I mean, semantic arguments are wonderful in philosophy because you need to define certain terms. You need to get to the basics of what a person means by something. And usually when I see debates, and because I've done many debates, and what I see most is people using words differently, and they're not on the same page, and all they end up doing is talking past each other. And it gets and I see that a lot even on this show and on other channels. And one thing that I like to do is get everyone on the same page, even if they don't have to agree with the definition. If they say, you know what, I think that's a crap definition, but I'm understanding how you're using it, that at least has a meeting in the minds, right?
Yeah, semantic was probably the wrong word for me to choose. When it comes down to, well, I'm just going to pull more details to help my side. How is that going to help if, you know, you and I we're not even totally sure what each other means when we use the word existence. So I'm creating what I think you mean by that and then arguing on that. But if that's nowhere close to what you actually mean, we're both, the talking past each other. And I see it in technical debates, you know, like in IT or whatever. I see it when I'm trying to pitch my research to companies to get them to fund it. You know, the hardest one is we all love anomaly detection, right? Anomaly detection is scary and sexy and fun. But if and they know they want it, I really want anomaly detection. What do you mean by that? What do you mean by that? If I can't get you on the same page, and the trouble I run into when I would pitch to this is I will try to explain when I say that I do work in what would be considered anomaly detection. I purposely use a financial term intervention in financial time series because it has a specific meaning. In other words, there's actually a mathematical definition and classifications of these things. So I would tell them this is what I mean when I say I study this, and they'll be like, yeah, but I really want anomaly detection. Like, okay, you don't like what's here, so what is it that you're looking for? You know, well, do you use like something that like uses machine learning? It's like, what am I supposed to do with this? Like, I can't, and it has very real consequences, not just in debates on shows, but you know, I can't get funding if we can't start on the same page and figure out, I can't help you, you know, from a business perspective, if we can't agree on a definition of what it is you're actually looking for, if you yourself have an obligation to define what it is you actually are looking for before you say, I just want anomaly detection. I mean, for one, you're going to get duped by someone that's going to sell you a bunch of crap and make you feel good about it. But it's also, you know, if you don't know how to define it, that's okay. We can work through that. And maybe the question is, we don't care. Maybe it's not anomaly detection you want. What is it that what's the problem? I need to be able to react to issues. I need to be able to react to, you know, predict a failure before it happens so that I don't lose a bunch of data. That's the real problem at hand. But if we can't move past that, and this is, like I said, I'm pulling a real examples. If we can't move past that, this has business consequences too. Not just me personally. Like, I mean, it has business consequences. It's not helping my potential customer. It's not helping me. If we can't agree on a definition of something or admit that we don't have one and have that as a starting point, we can't even do business.
But it's your job, I think, as a mathematician, to help the
Yes.
prospective customer understand their
Yes,
question first.
It's
And
really
they may
you're
even
looking for the
think
concept,
they understand
right,
the
though?
question.
Yeah, it's not so much the label. The labels are irrelevant. Like if I use a specific word, it's a philosophical term. We can relate the concept, right? The concept is more important than the label. And so when you're doing these things with your clients and your customers, and especially engineers, who, by the way, I think use mathematics a little bit differently than most people from my personal experience with mathematicians and engineers, not always just on the same page there. But you're asking them for what is you want to accomplish, what is your goals, and what is you're trying to do. Let me get there rather than what you're telling me what the name is. Because I've worked in customer service, and I worked in other things too, and I've seen the same problem. I mean, sometimes a customer is telling me something that they're using some kind of vernacular stipulative definitions that are not something that I'm familiar with. But if they tell me conceptually what they're going for, then I can help them a lot easier. Is something along those lines?
I find for some reason the tech industry gets really hung up on what buzzwords. That's what they are, and we cannot move past them because they're more obsessed with saying that they have the buzzwords than actually solving the problem, has been my experience. So I can try, and I'll try. Like, let's talk about what it is that what do you want to accomplish? What is the problem? You need to be able to process, you know, large amounts of data in real time and identify strange things. Let's call them strange things. That's fine. We can go with strange things for now, but that's what you're trying to accomplish. But if they can't move past I read a whole bunch of blogs on like Y Combinator or whatever that says that everyone's doing anomaly detection right now. I can lay everything out, you know, and try to help them solve the problem. But I have to then wonder sometimes, is it a problem that you want to solve, or do you just want to be seen doing something in the right space?
You want to be part of the market. I mean, I ran into a problem where there was a big machine learning thing that they wanted my assistance in. And so I decided, quote, let's throw some mathematics at it. And so I actually analyzed the problem, discovered there was a closed form solution, solved it, and came up with a very compact thing. I could actually solve it in what's called linear time. And I got yelled at. The reason why I yelled at is I destroyed the market. They can't sell large machines with lots of GPUs, wasting a lot of time because I came up with a solution that was that was closed form and deterministic.
I'm crying.
Right?
Wait, are you working with? Are you saying that you've solved like P equals NP in polynomial time? Is that what? No, you haven't got that far yet, right?
I actually understood their problem and chose not to use the current hype method of solving it.
And then
Gotcha,
you got yelled
gotcha.
at because they wanted to be seen using that method because it looks good in their PowerPoints and in their
It's more about the buzzwords and the catchphrases than it is
And,
the actual.
And one of the marketing complaints was I couldn't even show a graph of showing how their machines scale with the performance of this thing. It was just flat.
because it's irrelevant. It's closed form.
Yes.
right.
fact, our
In other
producers-
words,
yeah,
in other words,
sorry,
they got
Dave,
mad.
you guys-
In other words, because it was sexy and they didn't. It wasn't sexy and they didn't like it.
It wasn't sexed up enough. Yeah.
Safety's
Well,
important.
if you guys don't mind,
Safety's
we got a
important.
lot of questions from the audience coming in, but
Please,
most of them have already
please.
gone by, so they want to ask them again. Do you guys mind taking a couple questions? We're at the hour mark,
sure.
so I know your time, both
By
of
the
your
way,
time is valuable. So
And Steve, one of the things I remember in my college, Sunnyvale College, one of the big rip-roaring debates in the academic senate was the mathematics department tried to put onto the course curriculum a course on logic. And the philosophy department came up and said, wait a minute, that's our course. In fact, it's called logic.
Ooh.
And we tried to say mathematical logic. And then the law department came and said, well, we have a thing on logic too. And there's this big debate in the Senate over who gets to teach the logic course.
Because they're all different.
but
They're all agreeing on the definition.
sure, but there is a philosophy of logic, just like there's a philosophy of science, there's a philosophy of religion. There are
But the
philosophies involved
philosophy-
with these things, but logic. I would put logic under math. That's how I would put logic. Yeah, because those are logical structures. So
Philosophical
I would put
logic
mathematics.
is, yes, because physical logic is not mathematically logical.
Right, but there is a subject called philosophy of magic that deals with like for example, like a truth value. What is a truth maker for a truth of a proposition, right? But that wouldn't fall under axiomatic systems or logical systems. Why would it matter what a truth maker is, right?
But we had Professor of the philosophy department arguing that mathematicians don't actually prove anything because they don't understand what proof is and what is.
See, I would say the opposite. I think mathematicians are the only ones that can prove things.
I'm gonna say my fur's up. You just can't see it.
You have you an epi too? Do you agree or disagree? I think that mathematicians are the only ones that can say that they prove something, or logicians. But I mean, who else can prove things besides a mathematician?
Gosh, I'm gonna sound really pretentious and self-serving because that's what I do for a living. But yeah, I'm actually gonna say yes.
Okay. Yeah, I don't think that's really controversial, is it? Is it really controversial?
I have ceased wondering what it is that makes things controversial because I cannot dare
Valid
to say
point.
what controversial and what not anymore.
So
Now,
many things
Rachel,
are
someone
controversial
asked-
nowadays.
Someone asked you if you ever worked for NASA.
No. I have submitted research proposals to NASA that have been rejected. That's about my involvement with NASA.
Okay, so you're not a NASA
it's
shill,
over
and
for
you
you
can
now.
take the fifth on
You're a
that.
shill
You
now.
don't have to admit it. Yeah, you're just a shill anyways. And you
You're
do
one of
agree that
us
the Earth
now.
is not flat, right?
Of course.
Okay.
Again, things that shouldn't be controversial.
Oh,
if you
need
only
to
knew.
watch one of our flat
But,
If you
you know,
only knew.
I will say, that when I cured myself of flat Earth, notions back when I was about 20 months old, and then was told the Earth was round, I objected because I said the Earth is not round, it's lumpy, right? Because I was thinking round from a mathematical sense, and I could see mountains, and said, obviously, the Earth's not round because it's got lumps on it, right? And that was again a notion of different terms.
We have somebody who advocates that it's actually like a wavy potato chip.
Yeah, it's not
Literally
even
flat,
it's not
but
even
like
a
a
Disney.
wavy potato chip.
Yeah,
Yes.
like a sinusoidal kind of thing. Yeah, turtles
And
all
you
the
know
way
what the
down.
scary part
Yeah.
is? The scary part is that they're growing. They're not slowing down. There are more and more
serious?
people. There was a paper that came out about a month ago that said that what was it, a third, Steve? A third of millennials?
Yeah, I've heard
question
that.
shape
It's
of the
about
Earth.
30%.
Millennial
I don't
bashing.
know if I can agree with that, though.
No,
I think that's a
I'm
weird.
I'm a millennial
statistic.
too. I'm a millennial too.
So someone asked this thing, doesn't applied sciences prove things like stick hand in fire? I prove fire hurts and burns.
No.
Does that count?
No, you demonstrated it. You don't prove anything in science. Science. Every position in science is a tentative position. It's something that we take to be true as based upon the best knowledge of the time. As Dr. Traylor would I'm sure go into in express detail. You don't ever prove anything. You say here's my confidence. Here's my hypothesis. Here's my p-value. Here's what I can say. I can reject the null. Blah blah blah. And that's when they say, hey, look it. As far as we know, this is the case. And then every other scientist comes in and says, you know what, let me try to falsify that. And if you can, then you get props. And if you can't, then the kind of stays as the paradigm until somebody kind of falsifies it on Popper's falsificationism, which, by the way, is philosophy. Falsificationism is philosophy. But would you agree along those lines, Dr. Traylor?
Even to address the point of the if I stick my hand in fire, it hurts. A few issues with that kind of implication is, one, I can find counterexamples of people that cannot feel pain. So that aside, there's a counterexample, and two, the notion of hurt is not well defined, right?
The notion of fire is not well defined.
Well, yeah, even that, but I can inoculate myself. Like, for instance, as a hobby, I'm a marathon swimmer. That means, as a hobby, I swim between 5 and 10 kilometers as races. You train and inoculate yourself to the pain of lactic acid in your body. And so we can't even agree on what hurt really means. I can inoculate myself to like I said, we'll leave subcultures aside. You can inoculate yourself to pain to the point where you even enjoy it. So even that whole statement, nothing about that can even be defined objectively, right? Hurt is a relative thing. And I think that goes back to, if you want to measure pain and like damage to your body, that's starting to get pretty objective, right? Whether I feel it or not, that's getting objective. But we have to go back and redefine that very clearly before we can start to even address that question of, is that a proof?
And I can produce a chemical reaction, which you might consider fire, that would not harm you because of the temperatures and conditions involved.
So we have to agree on all of those pieces before we can start addressing that question. And that's something that I think, it's not sexy to do. But if I were basically from all this discussion, this is what mathematicians do for a living. And it doesn't just belong in the realm of mathematics. It even addresses points like this, and it keeps people from kind of, in some sense, getting scammed. If you're willing to
By the way,
really ask questions.
Sure. Here's a good question for you that I'd like to try. It says, can AI emerge if all they have is computational power? After all, they would run into completeness theorem problems, right?
Ooh, is that one aimed at me?
Sure.
So are we going to get a Terminator, which I love that franchise, by the way. Oh, I do. So Sarah Connor Chronicles, like small tangent, the show that ran for 2 seasons, Sarah Connor Chronicles, so good. Love that show.
It was a good series.
Okay. In a sense that yeah, and again, I try to, you guys are like forcing me into making philosophical opinions that I usually
That's the hard questions on here. Yeah, we're hard hitting.
Humans are creative, and honestly, am I worried about an AI takeover kind of thing? Okay, for one, have you seen neural nets? Like, come on. Have you seen self-driving cars right now? Come on. Am I worried about that? No. You know why? Because we have creativity, and that is not, I believe that is not programmable, right? That lateral reaching, which can also be termed creativity, cannot, right? A computer is simply a sequential set of instructions. That's what we do. Until you can figure out how to make a computer reach laterally, whatever that might mean, because I don't even know what that would mean. I'm not worried about an AI takeover, because ultimately we just have to interrupt the sequence. Even if we don't know what it is yet, we have to interrupt the sequence. You have people, mathematicians are going to get replaced by computers someday. No, they won't. We're too creative for that.
We don't even know
The
how
guy we have on
far
tonight
it
actually
happens.
says the exact same thing that you just did. The guy that is coming on tonight to talk about artificial intelligence, he says the exact same thing that you just did in our email back and forth, that it's overhyped for some reason, that people are way too concerned about a problem that probably won't happen.
I mean, we don't even know biologically what emergence of consciousness is.
Yeah.
Right?
Because one of the things is computers, it's very hard to get computers to do something so-called non-deterministically, right? So random number generator and computer are
don't get along.
really, yeah, and then one of the problems that she would trigger her was when you start talking about p-values and random, random numbers and randomness, right? You get so imprecise, you end up with a bunch of garbage at the bottom. And
Yes.
someone says,
What is your guys' take on stochastic systems as far as, I mean, do you think like the universe is deterministic, or do you think there's a lot more randomness in it than we would like to think? Again, back to a little bit of philosophical stuff, but what's that?
Well, like I said, even as a mathematician, and like I said, I stochastic analysis, and I, again, when I say analysis, that actually that's a specific branch of mathematics. So it's not just like looking at random things. There is, and I'm not a physicist, so I'm not going to claim to be. I do have a background in chemistry, but I am not a physicist. The notion of randomness, even if you move from, say Newtonian to quantum realm, things that looked deterministic all of a sudden have randomness that aggregates into something that looks deterministic. Once you zoom in enough, things get weird. So I do believe that. And that's part of what actually drew me into the notion of stochastic analysis, is that some people call it entropy, finance calls it volatility, you can call it noise. That study, and instead of just like setting it aside and like adding it into your deterministic system, but no, I mean building it into your model, your attempts at explaining the world, that's what drew me into the notion of probability theory and stochastic analysis in the first place, because I don't believe the world is deterministic. It can aggregate to things that we can predict with reasonable certainty in a lot of cases, like Newtonian laws of physics and their laws. But underneath that, it's just a matter of zooming, right? How far in are you zoomed? At a macro level, things look still, but when you zoom in, my glass of water or even my tea looks still, but if I zoom in, there's particles doing all sorts of shit in there, So it's a matter of perspective.
Now, the thing I was involved in something called Lavaran, and Lavaran was actually a hack on the patent office where we patented taking images of lava light lamps and generating cryptographic keys. And the big discussion I found, the big problem I had with that process, and by the way, there's a reasonable percentage of the internet that's actually encrypted using that method. But the problem I had was trying to convince people that chaotic and random are very different things, right? And the patent talks about a digitization of a chaotic system, seeding a pseudo-random number generator with the cryptographic hash of a digitization of a chaotic system was the exact title of the patent. But people said, oh, you're generating random numbers by taking pictures of lava light lamps. Well, no, and you had to talk about what's random and what's chaotic. Fortunately, in mathematics, you don't have the physics problem of you look at a proof and you're looking at it changes the proof. But this notion of what's random is a big problem.
Let me ask you, Landon, if you have a seed, whatever seed you come up with for a random generator, though, that is deterministic, though, is it not? I mean, it's not random at that point.
It's why they're called
pseudo-random, but it's okay.
That's the debate even in computational statistics, where if I'm going to create a random number generator or create a lottery game or whatever, you want to know how mathematicians have been able to break lotteries, because computers we cannot create a truly random number generator. I can write an algorithm for one, but when it comes to actually implementing that, because of that, yes, it is. I can get very close to random. In fact, I can show that it's approaching truly random, but a computer cannot truly be random, at least not the computers as we know them today. I'm not going to comment on what might happen, when I have a bunch of gray hair or whatever. But as we see them today, yes, even the random number generators that you use on your computer for whatever are not fully random in the actual definition of the word.
Yet people
You think of it-
then turn around and pull up mathematical terms and apply this pseudo math to these pseudo random numbers to do pseudo things. And those pseudo
Well,
things
let
are
me-
quite serious. For example, cryptography is a branch that needs a lot of mathematicians working in it because most computer scientists are cryptographically incompetent.
I was going to pipe in here and say that the pseudo randomness of computers has gotten better. Like
Yes.
when you had, like in the old days when you had the Commodore 64, you would
the
turn
VIC 20, yeah.
the VIC 20, you turn that thing on, you'd ask for a random number, and 2 days later you turn it on and ask for a random number, you get the same sequence of numbers. Literally.
Yeah, you put whatever number you're in, you're gonna get you if you put in like 2 as a seed, you're gonna get the same output every single time. That's why it's deterministic. It's not.
And by the way,
actually random by any means.
there are circumstances where you want that. But if you look, I mean, back again, cryptography, which is it's supposedly privacy protection, protecting financial information, etc. If you look at the track record of the IETF, and I'm going to tick off a bunch of people, the IETF has demonstrated year after year that it's cryptographically incompetent. Right? It produces results that are then broken later on, and one of the things is that they are built upon really fragile or flawed foundations. Right? And if you
Oh,
took a
that quote, can that
mathematical
quote be
approach,
like the tagline? That quote that Landon just put is the tagline. If you build on fragile foundations, as in you ignore the actual mathematics and definitions, you will crumble. Your specter,
Yes.
your meltdown, all of that junk.
yes.
That's what happens.
That's like building sandcastles in the sand. That's the same kind of approach. But somebody in the live chat said there's nothing actually ever random. And let me run it by you because I take a different approach. I think there is something called random. I'm looking from a different perspective than a mathematician would. So maybe you can kind of guide me on it. Certain things like quantum fluctuations are random. Certain things like spontaneous fission or weak nuclear decay are considered random under the Copenhagen interpretation. Right, Landon? There's no local hidden variables under those models. So would you say if in those cases that would be something that would be considered random because there's just nothing as far as information in that particular system to even be able to even determine when a weak nuclear decay is going to take place or spontaneous fission, correct?
Let me avoid committing mathematical sin by saying your measurements are unpredictable rather than it's random, right? Mathematically random means something very different than what physicists
yeah, but the problem
mean.
is it's not a measurement error, right? It's not problem measurement. It was, Einstein thought that that there would be variables that you can have a variable system, but the Copenhagen interpretation doesn't allow for global variables. There is one local hidden variable called pilot wave theory, but the actual quantum in Copenhagen interpretation is that there is actual randomness in the system. There's no ability whatsoever to ever make even a probabilistic argument of when a certain atom is going to decay or when a certain atom might undergo spontaneous fission. There's just nothing there. There's no hidden variable that we can say, hey, we don't know that variable. We're missing it. We can't find it. It doesn't exist. And there's a huge difference. If it doesn't exist, I take that as being random.
Oh, okay. So I'm gonna I think Landon struck on a good point. There is a difference between being random. There's the notions I'm seeing at play, and correct me if I'm misunderstanding, is the notion of random, the notion of unpredictability, and the notion of non-existence or non-observation, right? Some things we can observe, some things we can't observe. There's four central ideas at play. And none of those are either contained in another, nor are they equivalent.
I agree with that.
So, back to the definite, I think, so when I say that I believe that in general, the universe is ultimately random, I don't necessarily mean unpredictable. Because obviously, like, I can perform a linear regression and make a prediction, and then we can find out later if that was a good prediction or not. Yet the data that might generate that line has noise and thus might have random components. It's a little different. unobservable and random aren't necessarily the same thing either. Or even there's unobservable and then there's just simply we don't know what it is. Not known isn't necessarily random either. We just might colloquially use the word random because we don't know what it is yet. And sometimes it's nice to model it with noise because we don't know what it is yet.
Yeah, I think it really depends on your interpretation of the quantum mechanics. I mean, like I said, I think there's many different ways you can interpret it. Copenhagen many worlds hypothesis, and of course Bohmian mechanics or pilot wave theory. But to me, that's how I interpret it. I just think that if there's just nothing there, it is random. And as my background was in nuclear physics, so I used to train people to operate nuclear power plants. So when I'm looking at a system, then I'm thinking, okay, if there's a radioactive particle that's going to decay, if there's no way to tell ever, and it's impossible because there's just no information available, it doesn't exist, then when that particle decays is absolutely random. There's no determinacy for it whatsoever. That's how I particularly look at it.
I don't necessarily have a problem with the word being used that way because of how because you defined it and clearly defined it that way. If we want to then, and I cannot comment on physics, please don't make me do that. But now if we were to have a conversation about it, because we're starting off on the same foot, now I can work with that. Like, all right, if we want to call that random, that's okay. That's fine. We're talking about this concept, which we will now call random in this particular setting. So I'm not really necessarily objecting to you've actually defined it, but thank you.
That goes to the topic of our discussion. The fact is that if we define our terms and we're on the same page, then that I think is the goal for any good discussion. And I think that's what you seem to be doing in your profession is you want to be on the same page with the person. And even if your terms differ, conceptually, if somebody understands the concept, I think that's 99.9% of the, or if you really want to go there, 99.999 never mind. By the way, just to get on record, so I can timestamp this because I have two brilliant mathematicians here. 0.99 repeating is equal to
1.
Gosh, let me think about that one for a second.
I know don't strain yourself, Doc.
Which proof would you like me to use? To answer that question.
I know about 6 off the top of my head. I really do.
It's seriously like
that was the biggest dumpster fire ever.
I can't believe you drew me.
Do you know actually? That. I did draw you into that. I honestly did. We only got about 5 or 10 more minutes. We got to wrap up.
But let me.
One second. For people who don't know, I dragged her into this dumpster fire shit show on Twitter, and I feel bad about it. But at the same time, sorry, not sorry.
Don't. No,
I really don't. It was awesome.
So I think one of the things also to point out, so Steve, you produced a definition of random that was acceptable to us. Where you can come into problems is that now you've defined random. If you then begin to apply statistical theory and measure theory to what you're calling random, then you run into a problem, right? Just because you've defined random in some philosophical or physics sense doesn't mean you can then turn around and apply measure theory and statistical stuff.
How do you measure something that doesn't exist? What's the measurement of a point? A point has 0 dimensions, right? So what's the measurement?
Measure theory has a very precise.
Yeah, measure. But if you want to go into measure theory here.
No, measure theory. It's like ring theory. I don't want to deal with it. I mean, I told you earlier that I felt like an idiot because I called a p-adic system a field rather than a ring, and I had a group called Mathematician something or other correct me on. I was like, oh crap, they're right. Ring theory sucks. Don't do it.
Like we love that.
But here's the difference. What's that? Go ahead.
I said our hobby, besides like making sure everything's well defined, is poking holes in your stuff.
Yeah, but here's the thing. I don't mind that. Look, they corrected me. I was like, shit, they're right. And I was like, okay, you know what? You're right. And that's the difference. When like Landon or myself or somebody else is telling people about, like 0.99 repeating or something like that, the other people, they don't correct themselves. That's the difference. They don't recognize that they're wrong. I was wrong. I made a boo-boo. I'm sorry. I haven't looked at ring theory in a very long time. But when somebody brought it to my attention, I go, oh shit, I messed up. Okay. That's the difference, I think.
But to a mathematician, go ahead.
How do you even for instance, that dumpster fire you brought me into? that's I mentioned, like, how is this still going? I mean, there comes a point when, like, I mean, for me, I guess for my own sanity, there is no rational, we can't even have a discussion unless we both start from at least a premise of rationality. If you're going to refuse to start from that premise, forget everything. Like, there's nothing to be had. So I don't understand. I mean, you can't fight that. You can't fight what is ultimately, and I don't mean to insult anyone who is spiritual. You can't fight religion.
Right.
And it's not a matter of it's not a matter of debate. It's not a matter of opinion, right?
Right.
It's a fact. It's a mathematical fact, right? And if you continue to argue your opinion, you're doing something else.
Yeah, I don't know what that is. That's why I don't know how to respond to this. If multiple, not, and the fact is, like, just because there are multiple proofs doesn't make it like more right. You know, as long as a proof exists and it is correct, it's good. Just because there are 10 doesn't make this one more true. But the point is, like, you can even pick whichever way of proving that statement that is clear to you and lets you kind of get some insight as to the structure of why this is true. And you're being presented with all of these actual proofs, and yet you still insist on debating, if that's the word you want to use. There's nothing further. There's no further interaction I can have with you at that point. You know, I have no choice but to walk away.
Twitter's the worst place for debates.
Yeah, but it's okay to say that's a surprising result. Help me understand that deeper. Like,
yes,
that's totally different. Right. Yeah. But somebody just asked me. This is coincidence here. Somebody just asked me, or they didn't ask me. They said Steve can't Lebesgue integrate, and the paper that you had me read yesterday or the day before was on infinite probability distributions or Cantor theory, dealing with. I hate to pronounce this word, but is it Lebesgue? Is that how you pronounce it?
Lebesgue.
Okay, Lebesgue. Is it French?
Yes.
Okay, because you wrote a blog on this particular subject, and somebody just happened to mention it, and you don't hear that very often. That type of.
Oh, Lebesgue measure. Lebesgue measure is
Lebesgue measurement.
Powerful.
Yeah.
Yeah, that particular one. So I love edge cases. That particular one was the you know, what happens when we run into, oops, our system wasn't good enough. So in probability, you would have discrete distributions, like rolling a die, right? Probability is a sixth. That means, right, you have discrete sample space, if you will, right? The possible things that can show up as discrete. You have continuous ones, like the normal distribution, right? Your support is the whole real line. And then there's this weird little case that fits into neither one, which is where that blog post came in with the Cantor distribution, called a singular continuous distribution, where it broke. Broke. I use the term broke. It broke the system we had set up, and that case made us have to say, actually, there are 3 different classes of probability distributions, not 2. That's what that article basically was talking about, is this weird little edge case that you always have to check when you're trying to do something.
It surprised mathematicians and produced a result which was not expected. It didn't violate mathematics. It surprised us in a delightful way.
And we had to just simply, okay, well, instead of 2 categories, now we've expanded to have 3 categories of distribution. And basically, I spent probably a month and a half, because most probability textbooks don't touch that notion, because there's only 1 or 2 examples that have even been constructed. And again, it never shows up. We're going to ignore it, which is so sad. But yeah, so I'll write a case.
Now I'm just lost. I tried reading it. I said I'd never worked with Lebesgue measurements. I've never even heard the term, honestly, until yesterday or the day before yesterday. So it was a brand new concept even to me. And then just somebody happened to bring it up in the live feed, and I find that to be very coincidental. But I figured you might enjoy it because it's right up your alley, right?
Well, tell anyone, DM me on Twitter or whatever.
Well, there you go.
You know, if you want to reach. Yeah, I'm that person, right? If you're excited about something, like, be careful what you ask for if you want to start that conversation. But
yeah, I learned that the hard way the other day. I didn't know what the hell she was talking about, but it was fascinating. But anyways, we are pushing our time limit here, and we're going to have to wrap this up. So I really do want to thank both of you for coming in. This was I love these kind of discussions. I know, you know, people do like the dumpster fires, people like the flat Earth discussion, and I love them too. But I'd like to have these kinds of discussions as well. And I hope the live chat got something out of this. You know, I mean, we had
all
almost
necessary.
150 people watching, and people were telling us they love this. So hopefully they got something out of it. And if you don't mind, I can put your Twitter in the, but you might get inundated.
sure.
But I'll put your Twitter into the video description. So if anybody does want to ask you about Lebesgue
Yeah.
measurements, is that how you pronounce it? Lebesgue?
Yes, Lebesgue.
Yes, I got it
And
right.
Steve, I hope we can do this again because there's lots of areas of mathematics to explore without, and you notice without resorting to too many equations or too many, adverse reactions. You can actually have meaningful discussions with mathematicians that matter.
We're
so
human.
Hope we can do this again.
We are. Like, we eat food and have hobbies and,
Drink
And I'm
beer.
so glad you guys
You're
believe
not
in
automatons.
colors.
Yeah, they believe in
They-
colors. Well, you know what? They're brilliant mathematicians, but we'll leave the philosophy to the philosophers.
I mean,
Colorism for the win.
we're machines that convert caffeine into theorems. That's
yeah, that's about right.
All right. With that, I think we're going to kind of wrap it up. Again, I want to thank both you guys to coming in. Dr. Traylor, that was brilliant. And Landon, always a pleasure. And we will have many more conversations about math in the future. I guarantee it. So
I must say,
anything
Steve, before we
you'd
close
wanna-
off,
yeah,
since Landon is the reigning Jeopardy champion, when we do the debut episode of it on here, that means you have to come and defend your title, Landon. So we'll be seeing you next week again.
yeah. I mean,
And I'm making it
actually,
hard.
it was
I'm making
it
it
was
hard
a
next time for you,
difficult
Dave.
thing that the mathematical Jeopardy stuff really taxed because the problem is that they asked imprecise answers.
Yeah, it was crap.
And
Yeah,
then some of the questions are wrong, like the product rule. And
That was
the
pretty, yeah,
calculus
and I thought
rule.
product rule too. But
I was
it
correct.
was a product rule, but it's a power. I don't know why I said power rule, but it was the product rule, and I don't know how they messed that one up. But anyways,
Yeah. So
the next one's gonna be very difficult for you.
Oh dear.
Yeah, be
I
prepared.
think you'll be
All
fine.
right, with that,
Something tells me.
you'll be okay, man. Yeah, come on. But anyways, thank you guys for watching this. This was like one of my favorite things to talk about is math and
you.
science. So thank you very much for watching this, and we'll bid you good night. And by the way, the next show is at what time is that coming on, Kyle?
The same time we're always on in weekdays,
Okay,
8 p.m. Eastern.
Then 8 o'clock Eastern, 5 o'clock Pacific. Be there. Good night.
And
All right,
please
thank
be a
you.
Patreon to this show. Links in the description below.
Thank you. He shills for us. Thank you.
Yeah, there you go.
and actually, this discussion went perfectly with tonight's episode.